Hi, we are from Group 3. We are going to present about non-metal materials for biomaterials and food machine elements. So our group members are me, myself, Nur Aina Jiha binti Kamaruddin. We have Eng Chien Yi, Jia Chien, and also Sin Yi Pio. Alright, next. So for the first one is what is plastic? I'm going to present about topic plastic. What is plastic and type of plastic used for biomaterials and food machine elements? Give example of the machine elements and field of application. Next. Okay, so I'm going to explain first what is plastic. Plastic is any synthetic or semi-synthetic organic polymer. In other words, while other elements might be present, plastics always include carbon and hydrogen. While plastics may be made from just about any organic polymer, most industrial plastic is made from petrochemical. Next. So these are the example of the machine elements and field of application. Machine guards, bearing and bushings, star wheels, guide rails, gears, chain guides, and also flexible tubing. And the field of application is plant and machinery for meat, fish, and poultry processing, dairy produce, baked goods, and confectionery production. Next. So I'm going to explain about the type of plastics for the machine elements that I just listed just now. So for the machine guards, polycarbonate and acrylic sheet materials are ideal choices for machine guards. They are far more durable than glass and are easy to fabricate and install. Polycarbonate has superior toughness and impact resistance, and acrylic has superior clarity and it is stiffer than polycarbonate. Acrylic is often used for large unsupported machine guards when the impact resistance of polycarbonate is not required. Okay, and then plastics such as UHMW, which stands for ultra high molecular weight polyethylene, nylon, and acetal, have low friction and outstanding wear characteristics, even in the absence of external lubrication. These materials are widely used in high-speed packaging and conveying applications where wear resistance and smooth operation is essential. For UHMW, it is tough and durable. It performs well in applications such as chute liners and also star wheels where low friction and excellent wear performance are required. And then acetal is easy to machine into complex shapes. It has low friction and it has superior strength and stiffness compared with UHMW. Nylon has outstanding wear characteristics, particularly when it is in contact with metal in dry environment. Usually often used for gears, bearings, and bushings when long wear life is required and external lubrications needs to be avoided. And then next we have semi-crystalline PET, has strength and stiffness similar to nylon and acetal. However, it has superior dimensional stability and stain resistance. It is often specified for tight tolerance food processing machinery application. Okay, that's all from me. Next is Eng Chien Yi.
Very good. So I'm Eng Chien Yi, and what I'm going to present is what is elastomer and the type of elastomer used for biomaterial and food machine elements. Then I'll also give the example of the machine element and a field of application. Next. So before we discuss it, we need to know what is elastomer first. Elastomer is known as rubber or elastic polymer. It is a polymer with viscoelastic or viscous and elastic properties. Viscosity determines the flow resistance of the fluid on the surface contact, while the elasticity is the tendency of the object to return to the original shape after the tensive or compressive force is applied on it. The examples of elastomer or known as rubber are silicone rubber, nitrile rubber, and neoprene rubber in food industry. While in the biomaterial industry, the elastomers used are silicone rubber, nitrile rubber, and polyurethane. So these are the photos of the rubbers that I have just talked about. The silicone rubber is used in various applications in food and biomaterial industry. The nitrile rubber is normally used in food industry in which suction and discharge function in food and dairy industry. The neoprene rubber is applied with prolonged food exposure in the machine, while the natural rubber and the polyurethane is mostly used in biomaterial industry. Next. So why we use the elastomer to build the machine elements? It is because elastomer has high resistance to greases, oils, water, alcohol, acids, and or alkalis. Besides, it is flexible in design, so we can build various shapes by using the elastomer rather than metals or other else. And then it is chemical inertness. It has also has high stability in extreme temperature situations, so it can work in various conditions such as in mining or others. And then it has steam sterilization resilience, so it is very good in clean in place, or it can work with a high temperature. And it has favorable performance to cost ratio. It means that it can perform well, but the cost of the operation is not very high, so that the profit can be grown. And then finally, it has also high resistance to chemicals used in industrial cleaning and sterilization. Next. These are the elastomer grades in both food industry and biomaterial industry. In food industry, the elastomer grades are Food and Drug Administration, FDA, United States Pharmacopoeia, USP class number 6, 3A 18203 sanitary standards, or known as 3A, EC Regulations 1935 to 2004 and 2023 to 2006, or WRIS BS 6920 potable water. The elastomer grades in biomaterial industry are Food and Drug Administration, FDA, and United States Pharmacopoeia USP class 6 only. Next. So now we discuss the elastomer made machine elements. The first machine element that I'm going to discuss is butterfly valve state. The elastomer is used to construct the butterfly valve in food and biomaterial industry. The functions are to support and seal the valve when the valve is closed, to resist the wear and recession when it is in operation, to prevent the compressed or pump liquid or gas from leakage, and besides, it is also resistant to thermal friction and impact stresses. The second one is diaphragm membrane. It is used to build pneumatic control valves, solenoids, actuators, aggregators, and pumps. Normally, it is used to act as a seal system in those applications with suitable conditions. So before we need to build the machine, we need to observe the condition of the operation of the machine first before we build this machine. Next. Then it is gasket and pipe coupling. The gasket and pipe coupling are mechanical seals that seal the space between two or more mating surfaces or irregularities to avoid leakage from or into the joint objects while under compression. The abilities are anti-vibration, and it is hygienic, and also it has noise and sound reduction. It can hold up against extreme environments such as mining and deep sea. And finally, it has high resistance to chemical, no matter it is acid and alkaline, temperature and pressure. Normally, we can find it in the boiler, fuel tank, packing, and sealing device. Okay, then it is the O-ring. The function of the O-ring is to block a passage that may otherwise allow a liquid or a gas to escape. In the operation, while the machine is under pressure, the O-ring is squeezed against the opposite wall of the groove, keeping a perfect seal even under extremely high or low pressures. Since the elastomeric O-ring is springy, it returns to their original shape while the pressure is to maintain a seal and readiness for the next cycle. It is used to construct the pump, compressor, and other rotating equipment. And since the O-ring, the structure of the O-ring is like that, it can satisfy the static sealing locations on these complex and high-value assemblies. Normally, the O-ring will be inserted on the middle of the cover and the stage acceptor, just like the picture shown in the slide. Next. Okay, so that's all from me. Thank you.
Hello everyone, my name is Ong Kai Chi and my matrix number is 1948999, and I'm going to talk about the topic of what is composite. Composite is a combination of two materials or more with different physical and chemical properties. It is combined to create a material surpasses the performance of the starting materials. For instance, to become stronger, lighter, or resistant to electricity, or improve strength and stiffness. Next. Types of composite used in biomaterials and food machine elements. First is the glass reinforced polymers, which the short form is GRP. These are plastics which are reinforced with glass fiber. They are high corrosion resistance, strength, and high impact resistance. They are very low weight, non-conductive properties, ease of fabrication, and low maintenance. Particularly, it's used in industrial gaskets as insulation and to protect machinery and ensure safety. Second, the fiber reinforced polymers, which we call FRP, is a material made with a polymer matrix which is reinforced with fibers, mainly glass, carbon, fiber, or aramide fibers. It is strong, durable, long-lasting, and very low weight. And for the third one is the ceramic matrix composites, which is the CMC. It is a ceramic matrix. Composites are ceramic fibers embedded in a ceramic matrix to overcome the traditional weakness of the ceramic material, such as fractures, scratches, defects, and breaks. Next. Here is the example of composite materials used in food machine elements, which is graphite, a sintered metal, which we have all impregnated sintered bearings. Proprietary material featuring on added high-quality fine graphite powder to provide reliable lubrication for longer bearing life and superior bearing performance across all temperature ranges. And it is also approved by the FDA. And then there's also stainless all impregnated sintered bearings, which stainless steel powder with an magnesium additive for superior corrosion resistance as well as sliding properties and wear resistance. And then there's also self-lubricating graphite, which the first use of special graphite in the sintered metal industry with optimizations made to the material composition, enabling to use in environments not being suitable for oil lubrication. Next. And then another one is for the barrier, which is the plastic materials. It's plastic bearings, which the sliding material combining engineering plastics and super engineering plastics with a special filler material to achieve superior bearing performance. Besides, there's also plastic sliding screws, which is a lighter weight and lower noise by using a combination of barrier nuts and stainless steel rolling screw shafts, which can be used over a wide range of temperatures without additional lubrication and with superior corrosion resistance. There's also plastic rolling bearings, which the usage of materials that are self-lubricating and with corrosion resistance for the inner or outer ring, ball and retainer for superior water and chemical resistance can be used without any additional lubrication. And the last one is the plastic sliding bearing units. It has a superior water and chemical resistance. With greaseless operation means the unit can be washed. Easy installation as the bearing can be aligned and featured in an integrated housing and can be used at high temperatures. That's all from me. Thank you.
Next, you are going to see the glass. Next, so what is glass? It is scientifically defined as a non-crystalline amorphous solid that has the property of transparency and is used for practical, technological, and decorative purpose. And how it's made? The making process is forming by heating a mixture of dry solid materials until it reaches a semi-solid state. Then it will be cooled directly and immediately to prevent it from forming the crystalline structure that mostly the solid material has. Next. So basically, ordinary glass is manufactured by the composition of various substances like silica, lanthanum powder, oxide of alkali metals, calcium oxide, and so on. So the general properties of glass are soft surface, brittle, clear appearance, chemical inert, corrosive resistant, and so forth. Next. So one of the types of glass that used for biomaterials and food machine element is the soda lime glass. This is the most common form of glass produced, and it is composed of about 70% silica, 15% soda, and 9% lime, with much smaller amounts of various other compounds. So it's basically relatively inexpensive, chemically stable, reasonably hard, and extremely workable. Next, we will see the example of using this soda glass is the ball in the plastic glass ball bearing as shown in the picture. So the field of application is used in food and drug processing machine. Next. The type of glass is fiber glass that normally used in biomaterials and food machine elements. So fiberglass is a material made out of very fine fibers of glass. It is a type of glass which normally used in the plastic stringent. So the property of this fiberglass is resistant to heat and fire, lightweight, strong, less brittle, and its ability to get molded into various complex shapes. So the example will be the catch in the resin rolling bearing. So the field of application is in the food processing machine. Next. That's all for the part of glass. Next.
Okay, hi, my name is Cindy, and now I'm going to talk about ceramics. Okay, so first, what is ceramics? Ceramics is an inorganic, non-metallic solid made out of non-metal material that have been shaped and then hardened by heating to high temperatures. So the common examples that we can find in life are tiles, bricks, plates, and pottery. And normally for those common examples, ceramics that we found from the life are clay-based. But nowadays, like advanced ceramics are not generally just clay-based. Instead, they are either based on oxide or non-oxide, or combination of the two. The properties of ceramics are including high temperature resistance. By definition, ceramics can tolerate temperature of at least 1000 Fahrenheit, or also known as like 537 degrees Celsius. Besides, ceramics have high stiffness. Their stiffness is nearly twice stiffness of the steels. And the third properties of ceramic is they have excellent compressive strength. Long-term properties such as fatigue resistance and creep are usually good under compressive loads, and ceramics do not deform plastically or exhibit permanent elongation and reduction in area under load, even at elevated temperatures. Besides that, ceramics is inert. Ceramics do not degrade or rust when exposed to mold, chemicals, and water. And ceramics also has a property as an electrical insulation. These are the types of ceramics that material can be used in biomaterial and food machine elements. First and foremost is silicon carbide. It is known as semiconductor containing silicon and carbon. It is a refractory material with high melting point and has excellent thermal conductivity and low thermal expansion. It presents semiconductor characteristics. The next material is silicon nitride. It is known with good wear resistance. It also has high temperature strength and hardness with good toughness. It presents perfect thermal shock resistant characteristics. And the third example of ceramic materials is alumina. It is the most stable oxide known. And because it is inert to all chemical except fluorides, thus it is well suited for use in severely corrosive environments that would dissolve metals and plastics. Alumina also has advantages in field of high-speed machining comparing to the traditional high-speed steel. And the application of ceramics machine elements are usually in the machine with extreme operation environments such as vacuum environment, highly exposure to acid and alkaline. And these are the examples of the ceramic machine elements, including ceramic fastener, ceramic gear, ceramic screw, and also ceramic bearings. Ceramic bearings is usually applied in food processing and food packaging machines. And these are the features of ceramic bearings, including it has lower friction than conventional bearing due to a more spherically perfect rolling surface of ceramic balls compared to that of steel balls. Ceramic bearings have higher efficiency and reduced energy consumption compared to normal bearing made from a metal. And ceramic bearings are more durable and long-lasting. They also have the ability to work under heavy loads due to their high stiffness. And ceramic bearings are inert and will not corrode or rust when exposed to water, alkaline or acid, as might be customary during food preparation. The example of ceramic bearings in the market are angular contact bearing and Conrad bearing. So from the picture shown in the slide, we can see how the ceramic bearings looks like. They actually have in the market. There's two types of ceramic bearings. One is hybrided with the metal, and another one is full ceramic bearings. And the ceramic ball can be fabricated in various sizes. So these are the reference, and that's all from us. Thank you.